Okay, so here is the second homologous series that you need to know about for the IB. There is a follow-up worksheet to come with this, which I'll post for you. The alkenes. Okay, don't please get the two alkenes and alkanes confused. Don't write ALK, massive squiggle, NES, so hoping that you will get away with it. You won't. Okay, your writing has to be clear. It has to be clear that it says alkanes or alkenes. If it's a squiggle there, they'll assume it's wrong. So, what about the alkenes? Well, they fit the general formula CnH2n. Okay, unlike the alkanes, which have that extra +2 at the bottom, so they're slightly different. And the way in which they're different is that they contain an unsaturated double bond. That's a bit tautological, I suppose, saying an unsaturated double bond, but they're unsaturated hydrocarbons. They're therefore much more reactive than alkanes. This is an area of high electron density. There's the equivalent of 4 electrons here, and that means that this double bond is attractive to a species called electrophiles, electron liking in simple terms. Why are we bothered with alkenes? Well, first of all, a lot of the things around us, the raw material for them is an alkene. A lot of plastics are made from alkenes. There are other polymers that aren't made from alkenes, called condensation polymers, which you may know a little bit about, but our focus in this section will be all about addition polymers made from alkenes. If you get some olive oil and bubble hydrogen into it, it becomes solid. And there's a few other chemical processes have to go on. You need a catalyst as well. But hydrogenation of vegetable oils is used to make things like flora. Margarine is a bit of an old-fashioned term, but things like flora, can't believe it's not butter, and so on, are made by hydrogenation of unsaturated vegetable oils, polyunsaturates. And another key use, making ethanol, not for use in alcoholic drinks, but for use as a fuel. If you do D&V, you will know that when you use a trangia, you burn methylated spirits, which is mainly ethanol with some methanol added to it. So we need to become experts at naming alkenes, and it's very, very similar to naming alkanes, except you have to give an indication of where the double bond is. So this is called butene. The double bond is attached to the second carbon. Okay, not butene, because remember you use the lowest possible numbers. So it's attached to the first, second, so butene, not 2-butene, but-2-ene. Notice the hyphens in the middle there. And this one, where it's attached, the double bond is attached to the first carbon in the chain, is but1ene. It's not but3ene, 1, 2, 3, because remember you always name to get the lowest possible numbers. Okay, so now here's a little challenge for you. What I want you to do is draw out and name all the compounds with the molecular formula C5H10. Okay, I would put a significant sum of money on there being one that you will not get. Okay, it might be a risk with Senya around, but there'll be one I suspect you won't get. But have a try at that. It will take you a little while to do. Don't expect to do it in 10 seconds. It requires quite a bit of thinking about, but it is a key skill. You may well get asked to draw out and name compounds in your IB exam. So practice done now is good for you. Again, feel free to take a picture of what you've done and send it to me for checking. Okay, so alkenes undergo addition reactions. Now, in an addition reaction, two substances combine to form only one product. And during alkenes addition reactions, they go from being unsaturated molecules at the start to saturated molecules at the finish. Those of you that did GCSE will pretty much recognise all of these reactions if you've got a good memory anyway. So here we go. The first one, hydrogenation, the addition of hydrogen. Okay, here's nickel catalyst needed, 180 degrees centigrade. You need to know these sort of conditions. If conditions aren't stated, then that means the reaction occurs at room temperature and pressure. So what goes on? Well, there's the double bond. Oh no, it's disappeared. And what has happened is that one hydrogen atom has added to each end of the double bond. Sometimes you'll hear the phrase used, it's added across the double bond. So one H atom there, one H atom there. High level, you'll get a further understanding of how this reaction works later on. There's a simple form of it. Ethene becomes ethane. Key thing to remember is this sort of pattern, that part of the molecule goes on one end of the double bond, part goes on the other end of the double bond. And that's something you'll need to think about when you do the worksheet on alkenes. Okay, similar sort of pattern here. If we add a halogen, we form a dihalogenalkane. And look again, there we are, there's Br2, one gone to one end of the double bond, the other gone to the other end of the double bond, and what we form is called 1,2-dibromopropane. Dibromo, obviously because there are two of them, but 1,2 to indicate that one's on the first carbon atom and another is on the second carbon atom. Okay, or one's on the first carbon atom, another's on the second carbon atom. It doesn't matter which way you do your numbers for that particular example. Okay, again, the reaction has occurred at the double bond, nowhere else in the molecule. And if you want to go onto the presentation and watch the video, feel free. It's not very exciting. All it does is show you that bromine water can be used for a test for unsaturation, and with an alkene, the bromine water turns colourless. With an alkane, the bromine water does not react. So it stays that reddish sort of brown colour. Okay, reaction number 3 is called, as your long word for the day, hydrohalogenation. This is where you add hydrogen chloride, hydrogen bromide, etc. and you form a halogenoalkane. Okay, the key thing that people get confused here is that they still want to put a second bromine on there. It's HBr you're adding, or HCl or whatever, so you get one H at one end of the double bond and the other H and the Br at the other end of the double bond. Okay, you'll find out at higher level there's a little bit more to this. If I've got HBr and add it to propene, there are two possible products, and we'll find out which is formed, and we'll hopefully explain why at higher level. So bromoethane, that is called. You don't need to put the one bromoethane, because no matter where that bromo is in that particular molecule, it's in position number 1. It can't be anywhere else. Okay, then hydration, reaction with water, can be done in two different ways. The slightly old-fashioned way is to use concentrated sulfuric acid and form something called an alkyl hydrogen sulfate. I don't know what's kicking off in Scarborough at the moment, but there's quite a few emergency vehicles you may be able to hear around. The sulfuric acid is regenerated at the end of it, so that means effectively the sulfuric acid is a catalyst. But there's the first step. That substance there will be called ethyl hydrogen sulfate. If you've done your expertise on naming alkanes, that C2H5 with a spare bond on the end is called an ethyl group. And then the next step is welly in the water. Oh look, there's the sulfuric acid added. The double bond, remember, was there. You've got hydrogen at one end and the OH at the other. Okay, there's just the two equations in shorter-hand form. And here's the second way, direct hydration. This is the way far more used in industry these days. It's really quite fast, and it's actually a preferable way to making alkenes, to making alcohols, in particular ethanol, than fermentation. So there we are, just one step. Note the catalyst you need, note the temperature you need, and note the pressure you need. So quite forcing conditions. Okay, and I want you to stop the video and have a think about the advantages and disadvantages that this method has over the production of ethanol by fermentation. There are a few. Okay, see if you can come up with them all. Have you stopped the video? Come on, why not? I want you to do some thinking now. Okay, the disadvantages this has is that it's from a finite resource. Ethene comes from crude oil via cracking, so that's a finite resource. So that's the main disadvantage. It's actually expensive to set up as well, but it's a continuous process. It's very, very fast. Comparing with fermentation, fermentation takes several days to do, and fermentation is a batch process. But fermentation is done using sugars, and sugar, of course, is a renewable resource. Okay, so that's the sort of random question you might just get come up in your exam. It's not clear on the syllabus that you need to know that, but it's something definitely worth thinking about, maybe for one of those strange nature of science questions or whatever. Now, addition polymerization. A polymer is a long chain molecule formed when lots of small molecules called monomers join together. And the simplest example is polyethylene, which you may well call polythene or polyethylene in some places. It's made from ethene. Again, you may be familiar with those sort of pictures from GCSE. What I've done on the next couple of slides is slightly erroneous, in that I've accidentally put all the answers to the questions. It's all meant to come in on sequence, but I've failed dismally. What you need to be able to do for the IB, though, is go from that, the monomer, to draw either the whole polymer structure or sometimes just the bit that's within the brackets, which is called the repeating unit. You can also be given that and be asked to draw the monomer. So please have a look at the next couple of slides and check that you can spot the sort of pattern. Okay, I'm going to click through them very quickly on here now, but you can get the presentation up and look at them a bit more slowly and carefully. Okay, so I've also added in some uses and some of the common names that you may have heard of for some of the polymers. So that's the first slide of them, and that's the second slide of them. So check that you can spot the pattern. Okay? Right, now that puts us at the end of alkenes. Okay, so that's plenty for you to go through, certainly for a lesson. What I want you to do is join a Google lesson or so, I should say, because drawing out C5H10 will keep you quiet for a fair bit of time, and making sure you haven't got any repeats. What I want you to do after that, if you have some time for the rest of the week, is join the Google Classroom that I'm setting up for IAs. There'll be a template on there for you to use to do your IA, so I can monitor what you're doing, and there'll be a form for you to fill in with your basic ideas.